In this tutorial, we are going to solve some questions under Newton's laws of motions. These questions, I've gotten them from different past papers from different universities. So I've got a number of questions with me here. So let's start. In a car of mass 100 kgs moving at 20 meters per second on a horizontal road is brought to rest by braking over a distance of 25 meters. So now the question is, find the average braking force. So to find the average braking force in this case, we have first to find the acceleration. Once we find the acceleration, then force is equal to mass times acceleration, since we have the mass already there. So what we're going to do, we're going to say, here is our car. Okay, so I'm going to say I have got a car here. Come up with a free body diagram. So this is my free body diagram. This car has got a mass of 100 kgs. They are saying that the initial velocity it was using, it is 20 meters per second. Now, how do you know that this is the initial velocity? Because the question is saying it was brought to rest, meaning that it was moving away from this point all the way to this point, meaning that at this point, when it was brought to rest, it was not moving, meaning the final velocity is 0. It covered a distance of 25 meters. Okay, find the average braking force. We need just to find we need to find the acceleration. So to find the acceleration, since it was brought to rest, meaning the acceleration is going to be negative. So we don't have time. The only formula which can work is v final squared is equal to v initial squared plus 2md. The final velocity is 0. The initial velocity is 20 squared plus 2. Acceleration we don't know. The distance is 25. We shift this to the other side. We're going to find that we're going to have this is going to be equal to 2 times that one is going to give us 50. We divide it by 50. We divide it by 50. Acceleration is going to be 20 squared divided by 50. So it's negative 8 meters per second squared. That was the acceleration now. So force is equal to mass times acceleration. Force is a vector. Definitely it can be negative, but we are going to get just a magnitude. That's just okay. So to find the average braking force in this case, the average braking force is going to be, the mass is 100 times negative 80. So our force is going to be negative 800 newtons. So this is the average braking force in this case. That is it for this question. So here's a question for you. Suppose, as shown below, that 100 kg box is pulled by a 500 Newton force at an angle of 40 degrees to the horizontal. The coefficient of kinetic friction is 0.5. Find the acceleration of the box. Now, we know that force is given by mass times acceleration. So they want us to find the acceleration. Now this force, it has been applied at an angle. What we have to understand is that if you have got an object which is being put on horizontal table, let's say the force is 100 newtons. Okay, and let's assume to say there is no friction at all. To find the acceleration in this case, you are going to be given the mass over the block. Let's say the mass of the block is 20 kgs. To find the acceleration, you are going to say the summation of the forces in x direction The only force which we have in this case, or the force which is acting in x direction, is the applied force, which is going to be the applied force, meaning that this is going to be replaced with the mass times acceleration. So ma is going to be equal to the force divided by m divided by m. Acceleration is going to be equal to, in this case, the force is 100 divided by 20. Okay, meaning that if I say 100 divided by 20, my acceleration is going to be 5 meters per second squared. We don't have friction. Now let's assume to say we have friction. Okay, we have friction. So friction is opposing the motion. So let's say mu is 0.5. Mu k is 0.5. Find the acceleration. To find the acceleration in this case, we're going to say the summation of all the forces in x direction. We're going to have the applied force minus the friction force. Friction force carries negative because it is opposing the motion. So friction always opposes the motion, so it has to carry a negative. Now, according to Newton's second law, we replace this with mass times acceleration. So this is going to be m. A is going to be the force minus the friction force. Okay, so we divide both sides by m. We can see that acceleration is going to be force minus this friction force is mu times the normal force. Now normal force in this case, we know that this is going to be the mg, which is the weight of this block. Then you have got the normal force. So in this case, we say the summation of the forces in y direction to find the normal force is going to be then the normal force minus the mg. Since this object is not moving in y direction, therefore the net force is 0. So this is going to be replaced with what? 0. So we're going to have 0 is equal to this minus mg. I can shift mg to the other side and you're going to see that Fn is going to be mg. Okay, now we divide it by m. Now you can plug in the values here and find the acceleration. Now let's assume to say the force is applied at an angle. If the force is applied at an angle, there is friction. We need to do something else for us to find the acceleration. Now in this case, we can see that we have got the force in y direction. We're going to have the mg, but this force is applied at an angle, meaning that we have got the fx and the fy, but at the same time we have got another force in y direction, which is the fn. Okay, now the friction force is opposing the motion, so the friction force is going to be there. Our goal is to find the acceleration. Remember, this object is moving in x direction and not in y direction, meaning that the net force in y direction is going to be 0, but we have the net force in x direction. So to find the acceleration, we're going to say the summation of all the forces in x direction. What forces do we have in x direction? We have fx, which is pointing toward positive x-axis, minus the friction force. Friction force is opposing the motion. Now since there is acceleration, we're going to replace this with mass times acceleration. So it's going to be mass times acceleration is going to be friction force is mu times the normal force. Okay, minus, this is just the fx. Okay, so this fx, using SOHCAHTOA, we can see that fx is going to be f cos theta, fy is going to be f sin theta. So where there's fx, we're going to put f cos theta minus friction force is mu times the normal force. Now to find the normal force in this case, first I'm going to divide here by m, here by m. Acceleration is going to be f cos theta minus mu times the normal force. Everything divided by m. But let's first find the normal force. To find the normal force, we are going to say the summation of forces in a y direction. What forces do we have? We have the Fn, which is pointing toward positive y-axis, plus also Fy pointing toward positive y-axis, minus the mg. Okay, so mg is opposing the motion. Now, since the net force is 0, this is going to be replaced by 0. So if this is going to be replaced by 0, then it's going to be 0 is going to be equal to fx plus, this is fn, then fy minus mg. Okay, now what we have to understand here is that our goal is to make fn as a subject of formula. I'm going to shift these two to the left hand side, and I'm going to end up having mg minus Fy, but Fy, we know that Fy is Fn, is F sine theta, is going to be equal to the Fn. Meaning that where there's Fn, I'm going to replace with this and find the acceleration now. Meaning that A is going to be F cos theta minus mu. Where there is Fn, I'm going to put mg minus F sine theta. I divide it by m. Now, if I plug in the values and find the value of A, that is going to be my acceleration when there was what? Friction. So let's plug in the values, we see the answer which we're going to find. Let's see the answer which we're going to have. So our acceleration is going to be, our force is 500, then we have cos the angle is 40 degrees minus the mu value is 0.5. Okay, then the m now which we have is 100, the g is 9.8 minus the f is 500, we have sine 40. Now we divide everything by what? The mass, which is what is our mass? Our mass in this case is 100. Now let's see the answer which we're going to have. So we have what is 500 cos 40? I'm getting 383.02 minus. So inside here I'm going to have 100 times 9.8. 100 times 9.8 is 980. So 980 minus 500 sine 40. So this is giving me 658.606 times 0.5. So this is giving me 329.3. So I'm going to divide this by 100. So my acceleration in this case is going to be 383.02 minus 329.3. I divide it by 100. I can see that my acceleration in this case is going to be 0.54 meters per second squared. So that is it for this question. Here is our next question. So the question is saying a 450 Newton force directed at an angle of 35 to the horizontal is applied to the top edge of 30 kg box. It is set in motion and achieves a velocity of 1.5 meters per second in 3 seconds. What is the coefficient of friction between the box and the floor? So the key point here for us to know, to say 1.5 meters per second is the final or initial velocity. So the question here is saying from this point here, from this point, is saying it is set in motion and achieves a velocity of 1.5, meaning that definitely it achieved this velocity, meaning this velocity is the final velocity. So we can assume to say, since we have not been given the initial velocity then is 0. Okay, so they want us to find the coefficient of friction. Now to do that, as we can see, the previous question, I think we are finding the same thing, but it's just a bit different here. So what we have to know here is that this force is applied at an angle, meaning that this force is going to have the vertical component and the horizontal component. So we can say that we have got Fy of this force pointing up, downward, and the Fx. Now we need to be very much careful here. We need to be following the arrows. So this force is directed in this direction, meaning that the y component is going to be following there, is going to be directed downward. If you have a force which is pointing in this direction, meaning that the y component is going to be directed upward. Okay, using vector analysis. Now from here, now we can see that if we do the summation of all the forces, now we know that if there is friction, meaning friction is opposing the motion, meaning that the summation of all the forces in x direction, since this object is moving in x direction, we don't expect to have forces in y. The forces in y direction, they are going to be, the net force is going to be 0, meaning the object is not moving in y direction. So this object is moving in x direction, therefore the net force, or the summation of all the forces in x direction, we're going to have the fx, which is pointed toward the positive x-axis, minus the friction force. Remember, friction force always opposes motion. So it is opposing motion, it's going to carry a negative. According to Newton's second law, we need first to find the acceleration. Once we find the acceleration is going to help us to know the coefficient of kinetic friction. Okay. Now, how do we find the final velocity, or the acceleration in this case? But first, let's come up with this formula. So we're going to have mass times acceleration is going to be fx. Using SOHCAHTOA, fx is going to be f cos theta, and fy is going to be f sin theta. As simple as that. Meaning that fx I'm going to replace with f cos theta minus friction force is mu times the normal force. Now we need to find the normal force. In this case, we know that normal force is directed upward, and the weight force is directed downward, which is mg. So we are going to say, how many forces do we have in y direction? Now we have 3 forces. We have this force pointing downward, this force pointing upward, this force pointing downward. So we're going to say the summation of all the forces in y direction, we have the normal force pointing upward minus the fy pointing downward minus mg pointing downward. Since this object is not moving in y direction, the net force is 0. I'm going to replace this with 0. Okay, but when there is acceleration, you only replace this with mass times acceleration if there is acceleration. So in this case, this is going to be 0. We're going to have fn. We know that fy is going to be f sin theta minus mg. Now to find fn, I'm going to shift this to the left hand side. Therefore, I'm going to have fn sin theta. Since it's negative, this side is going to be positive. So I'm going to have this is going to be equal to fn. Meaning that in this formula here, where there is fn, I'm going to replace what? I'm going to replace f sin theta plus mg. Okay? Meaning that I can now get rid of this. I no longer need this. You now get rid of this. So what I'm going to have now is I'm going to have mass times acceleration is going to be equal to f sin theta minus, I'm going to have mu open brackets f sin theta plus mg. Okay, now remember, we want to find the mu value. So what I'm going to do now, I'm going to shift this to the left hand side, and then I'm going to shift this to the right hand side. Okay, as simple as that. So let me get rid of this. So I'm going to say this is going to be mu open brackets f sin theta plus mg has to be equal to f sin theta minus ma. Now from here, I can divide everywhere with f sin theta plus mg, even here f sin theta plus mg. Now we can see that these two can cancel. So our mu value is going to be equal to the f sin theta minus ma, everything divided by f sin theta plus mg. Now remember, we don't have acceleration in this case, but I can now get rid of this. We don't have acceleration. Yes. Now we need to find acceleration. We have been given the information there. We have the time. We have, what else do we have? We have the time and the velocity. So our goal is to find the acceleration. Okay. So once we find the acceleration, then we have everything to find the mu value. So acceleration, the data which we have here, we can use this formula. This formula can help us to find acceleration. We have the final velocity 1.5, the initial velocity to be 0, the acceleration we're trying to find, the time is 3. So we have 1.5 is going to be 3a. We divide it by 3, we divide it by 3. Acceleration is going to be 1.5 divided by 3. I'm getting 0.5. So this is going to be my acceleration, 0.5 meters per second squared. Now, if this is my acceleration, I have everything now. I can just plug in the values. So let's put acceleration here, 0.5 meters per second squared. Let's now plug in the values in this equation for us to come up with what? The mu value. So we are saying mu is going to be, the force is 450 sine the angle is 35 minus the mass is 30 times acceleration 0.5. So these I'm going to put them in brackets. I'll divide this with the force is 450 sine 35 plus the mass is 30 times 9.8. As simple as that. Let's see the answer which we're going to get. So our mu is going to be, on top there we're going to have 450 sine 35. So this is giving me 258.12 minus, what is 30 times 0.5? So this is giving me 15. So I'll divide this by, we have 450. Okay, so this one was supposed to be cos. I think the one for fx supposed to be cos and not sine. So which one was for fx? Let's just see here. The one for fx, I believe it was the one on top there, the one which is f sine theta. That was fx, supposed to be f sine theta. This part here, this part here is supposed to be, it is fx. So fx is f cos theta and not f sine theta. No. So here we need to put f sine cos theta, the fx, f cos theta. So now when I shift this one is going to be f cos theta, this part here. So we can even start from here. Okay, from here, in short, what we are trying to say here is the same formula, but this part here is supposed to be cos. Okay, this is supposed to be f cos theta, then this is the same. So we're going to have the same formula, but so it's going to be mu is going to be equal to f cos theta minus mm. This has to be divided by f sine theta plus mg. Yes, and remember we have found our acceleration already to be 0.5. Let's not forget, we have found our acceleration to be 0.5 meters per second squared. So we can now plug in the values. So we're going to have f is 450 cos 35 minus the mass is 30 times 0.5. Then we divide it by the force is 450 sine 35 plus the mass is 30 times 9.8. So what would be our mu value? So what would be 450 cos 35? This is going to give me 368.62 minus, we have 30 times 0.5, which is 15. Okay, I'll divide this with 450 sine 35. So this is giving me a 258.12 plus 30 times 9.8. I'm getting a 294. Now let's see what we're going to have there. So on top there, we're going to say On top there, we're going to say we have 368.62 minus 15. So on top there is giving me 353.62. So I divide this with 258.12 plus 294. So this down here is giving me 552.12. Now let's see. So our mu k in this case is going to be, we have 353.62. We divide it by 552.12. So this is giving me 0.65 as our coefficient of friction. So that is it for this question. Okay, so here is our next question. The question is saying the speed limit along a certain road is 80 kilometers per hour. To stop at a junction, the driver applied excessive force on the brakes and skidded for 55 meters before stopping. The coefficient of kinetic friction, mu k, between the tires and the load is 0.75. Determine if the driver exceeded the speed limit. Okay, so let's assume to say you are moving from point A all the way to point B. Okay, so we're going to call this as point A and this as point B. So here is our point A and here is our point B. Now here is the car. So this car is moving from point A all the way to point B. Okay, so here is our car. So this car is moving in this direction. So that is the direction of the motion. Now they are saying that the speed limit for you to move from point A all the way to point B is 80 kilometers per hour. So this person covered a distance of 55 meters. Okay, saying that this person covered a distance of 55 meters, then the coefficient friction between the tires and the load is 0.75. Now the question is, determine if the driver exceeded the speed limit. So we have to find the initial speed. We know that when he applied the brakes, then he skidded for about 55 meters. That was the distance, meaning that there was a friction force which was acting on this car. Now what is happening here is that the only force which is acting in this car is just the friction force. Now that friction is opposing the motion. They have only mentioned about friction force. Okay, now we do know that friction force opposes motion, meaning that for us to find the initial speed, when it reached at point B, the final velocity at this point is going to be 0 because it's going to come to stop. Now the initial velocity we don't know. It's the one we are trying to find. Okay, so that is what we are trying to find. Now we are trying to find the initial velocity, but we don't know the acceleration. To find the acceleration, we are going to say the summation of all the forces in x direction. What forces do we have? The forces which are acting on this car is the friction force only. Now the friction force is opposing the motion. The car is moving in this direction, but the friction force is pointing in the opposite direction. So this friction force is going to carry negative. So we're going to have negative Fk. According to Newton's second law, we replace this with mass times acceleration. So mass times acceleration is going to be negative mu k times the normal force. Normal force in this case is going to be mg. So we're going to have ma is going to be negative mu mg. I'm going to cancel the mass. I'll cancel the mass. So I'll have a will be equal to mu g. Acceleration is equal to negative 0.75 times 9.8. So what is 0.75 times 9.8? I'm getting my answer to be negative 7.3 0.35 meters per second squared. This negative is just telling us to say it was decelerating. Okay. Now, we need to find the initial velocity. We have now the acceleration. The final velocity is 0. We don't have time. We have the displacement. The only formula which can help us to find the initial velocity where we don't have time is the third equation, where we are going to say v final squared is going to be v initial squared plus 2ad. Our goal is to find the initial velocity. Final is 0 squared. The initial is the one we are trying to find. The acceleration is negative 7.35. The distance is 55. Let's see. We shift this initial to the other side. It's going to be negative initial squared is equal to. So this is going to be negative 7.35 times 55 times 2. I'm getting 2 times negative 7.35 times 55. I'm getting negative 808.5. So negative and negative will cancel, therefore we're going to have this. So we get the square root both sides, even here the square root both sides. V initial will be equal to, if we get the square root here, we can see that we're going to have a 28.43 meters per second. That is the speed, the initial speed which this driver was using at that point. Now the question is, determine if the driver exceeded the speed limit. So we have found that the initial speed is 28.48 meters per second. Now we have to convert this speed into kilometers per hour for us to see if it exceeded the speed limit. The speed limit was 80 kilometers per hour. So it's either you can convert this, put it in meters per second, or convert this, put it in what? Kilometers per hour. So let's just convert 80 to meters per second. Converting that, what we're going to do is we're going to say 80 kilometers per 1 hour. In 1 kilometer, how many meters do we have? We have 1,000 meters. Now in 1 hour, how many seconds do we have? We have 3,600 seconds. Now these are going to cancel. This is going to cancel. What we're going to remain now, our answer is going to be meters per second. Now we can see that we're going to have 80 times 1,000. Then we divide it by 3,600. So I'm getting the speed limit was 22.2 meters per second. So as we can see, the driver exceeded the speed limit, because the speed at which the driver was traveling at is a bit greater than the speed limit. As simple as that. So that is it for this question. So our next question is saying a man slide a crate at a constant velocity along a horizontal floor by pulling on a rope attached to the crate at an angle of 30 degrees to the horizontal. The crate weighs 50 kg and the coefficient of kinetic friction between the crate and the floor is 0.65. Find the tension exerted on the rope. So first, it is very important for us to understand the question. If we are to understand this question, there is this point here. They are saying along a horizontal floor. So you need to say this is, come up with a free body diagram. So a free body diagram is going to help you to know the information which is there. So we can see that here is our crate. Okay, let's put our crate here. Now this crate is 50 kgs. Now they are saying that a man size, so we are going to use a rope. So this is going to be our rope here. Okay, if here is our rope, so they are saying that the angle which is going to be there is what? 30 degrees. Meaning that this force which we have here, let me use different color. This force which we have here, guys, this force is going to have the horizontal component, which is going to be the Fx, and the y component, which is going to be pointing upward. Remember, when the angle when the vector this is a force vector is going in that direction, meaning that you're going to have the x component and the y component in that case is going to be directed upward. That is going to be the y component is going to be upward. But if a force is in this direction, let's say it is applied here, okay, meaning that that angle, the y component is going to be directed downward. But now, how do you know here to say it's supposed to be in this direction? Okay, the question is saying a man slide a clit at a constant velocity along horizontal floor by pulling, meaning you are using a rope, you are pulling it, meaning that that force is going to be directed there, and you cannot pull unless if it was saying pushing. Okay, pushing, yes, you can push it at an angle, but you were pulling, it was just being pulled. That's why it's going to be directed in that manner. Now there is another point here. The question is saying a man slide a clit at a constant velocity. Once you hear constant velocity, just know that the acceleration is zero. The net force is going to be zero. Okay, now again here there is friction, meaning that there is a force which was opposing motion. That force is the friction force. The question is find the tension. So to find the tension in this case, we are going to say the summation, it was moving in x direction, the summation of all the forces in x direction. What forces do we have? We have fx, which is pointing toward positive x-axis, minus the fk. Fk always opposes motion. According to Newton's second law, the net force here is zero, so we're going to replace this with zero. I'm going to say zero is going to be equal to, so we know that fx in this case is going to be f cos theta, and fy is going to be f sin theta. Let's plug in the values. So we're going to have fx is going to be f cos theta minus, this is mu times the normal force. To find the normal force in this case, we have got three forces. Normal force is directed upward, mg is directed downward, which is the weight force. Therefore, we're going to say the summation of the forces in y direction. We have got two forces pointing upward, fn pointing upward plus fy pointing upward minus the weight force, which is mg pointing downward. This is going to be replaced with zero because we don't have the motion in y axis. Zero is going to be fn minus fy is f sin theta minus mg. So this is plus, sorry. Now from here we want to find fn. I'm going to shift these two to the left hand side, meaning what we're going to have now is we're going to have mg minus f sin theta is going to be equal to fn. So where there is fn in this equation, we're going to replace it with mg minus f sin theta. So I'm going to say 0 is going to be equal to f cos theta minus mu, where there's fn I'm going to put mg minus f sin theta. Remember, our goal is to find the force, so let's distribute. I now no longer need this. Okay, I can get rid of this, meaning that what I'm going to have here is going to be, I can distribute that one. So here we have 0, let's not forget. So we're going to have 0 is going to be equal to f cos theta minus mu, I'm just expanding that one, mu mg plus mu f sin theta. Okay, so now our goal is to find the force. I'm going to shift this to the left hand side. Okay, so shifting this to the left hand side, we're going to end up having mu mg is going to be equal to f cos theta. Okay, f cos theta, then we are going to have plus mu f sin theta. Now I can get rid of this to create space. So we're trying to find the tension force. If you want, you can say is T. You can say this force is T, and it's going to be Tx. So if you say this is T, this is going to be Tx, this is going to be Ty, which is the tension force. So there's nothing wrong even if you use Ft. Okay, so even here I can just use Ft, even here I can use Ft. Okay, even here Ft, meaning that I can start writing this, which is just the same thing. I'm going to say I have Ft. I can now get rid of this even, because I no longer need the free body diagram. So I have now Ft cos theta plus mu Ft sin theta is equal to mu times mg. Now from here what we need to understand is that I can factor out the Ft, because my goal is to find the Ft. So I'm going to say open brackets, I'm going to have cos theta plus mu sin theta. This is going to be equal to mu times mg. So we can divide both sides by cos theta plus mu sin theta, even here cos theta plus mu sin theta. So what we're going to have now is going to be Ft. Our formula for Ft is going to be mg, mu mg, everything divided by cos theta plus mu sin theta. Let's plug in the values, we see what we're going to have. So what is our mu value? Our tension force is going to be mu is 0.65 times mass 50 kgs times 9.8. Then we divide it by cos 30 plus mu 0.65 sin 30. So let's see what we're going to have. So our tension force is going to be, going to say 0.65 times 50 times 9.8. So on top there is giving me 318.5. We divide it by, we have cos 30 plus 0.65. Okay, so let me just say I have cos 30. Okay, what is cos 30? Or I can even start with 0.65 sin 30. Then the answer I'm going to find, I do plus cos 30, which is giving me 1.191. So if I divide here, my tension force is going to be 318.5 divided by 1.191, which is giving me a 267.42 newtons. So that is going to be my tension force in this case. Okay, so that is it for this question. So the question is saying, in the figure shown below, the two block of mass m0, which is 2 kgs, and m1, which is 5 kgs, are connected on a horizontal frictionless table and pulled to the right with a force of 40 newtons. Calculate the acceleration of the masses and the tension T in the cord connecting M0 and M1 if the table is frictionless. So they want us to find the acceleration and the tension if the table is frictionless. Then 2, they want us to find the same acceleration and the tension if we have the friction. So if the friction between these two blocks is the coefficient of friction is 0.4, then we need to find the acceleration and the tension. Okay,